Okay, question two. We have another cubic, and question A is asking us to use the factor theorem to show that x minus 2 is a factor. If we read ahead, we've then got to basically factorize this cubic by taking the x minus 2 factor out, and then we have to show that, in fact, the factor that we found, or the root x equals 2, is in fact the only real root. So thinking ahead, the factor theorem is a very specific thing. You cannot answer part A by doing a long division. Um, you may want to do long division for part B, but it doesn't get you any marks in part A. You have to use the factor theorem, and the factor theorem says that if x equals A, sorry, not x, if x equals A, if f of A equals 0, then x minus A is a factor of f of x. Okay, so this is what we have to use. So basically all we have to do is we have to show that f of 2, which is 3 times 2 cubed minus 7 times 2 squared plus 7 times 2 minus 10, which is 3 eighths are 24, 7 fours are 28, 2 sevens are 14, minus 10. That should be 0. It's minus 4 plus, yes, it is in fact 0. Therefore, x minus 2 is a factor by the factor theorem. You don't have to write this first line that I wrote. I was just writing that down to show you what the factor theorem was. Okay, but you do need to you need to mention it, really. It's asking you to use the factor theorem, so you need to show that you've used it. Okay, it's no good just writing half the answer. Okay, now question B, I think most of us would do this by division. You could do it by matching coefficients. So you could let the polynomial equal x minus 2 brackets ax squared plus bx plus c, and then expand and match up the coefficients. That would be an alternative. I'm going to do division here. So I'm going to do x minus 2 into the cubic, which is 3x cubed minus 7x squared plus 7x minus 10, double checking all along that I'm not making any errors in copying it. And then here we go. So the first term is going to be 3x squared. Multiply that, 3x squared minus 6, sorry, 3x cubed minus 6x squared. And then subtract. Minus 7 minus minus 6 is minus 1. So it's minus x squared. Bring the next term down. I need to now have minus x to match the minus x squared. So that will be minus x squared. Why have I written x squared there? Minus x. So minus x squared plus 2x. Subtract 7, take away 2 is 5, so 5x. Bring down the minus 10. And then if all is well, which it is, plus 5 gives me 5x minus 10. Always nice to finish it off just to show that you get 0 at the end rather than sort of leaving it unfinished. So my quadratic term is the quotient here. So therefore, to finish it off again, f of x equals x minus 2 brackets 3x squared minus x plus 5. It does, the question says find the values of a, b, and c. I suppose it's quite nice. I don't think it's essential, but to finish off to say a equals 3, b equals minus 1, and c equals 5. Not totally essential, but that is what the question asked us to do. So nice to do that. Okay, so question C, we now have to show that there's only one real root. Uh, so perhaps we should point out, so x, what we have is f of x, which is x minus 2, 3x squared minus x plus 5 is equal to 0, implies that x minus 2 equals 0, or x 3x squared minus x plus 5 equals 0. Now this gives us x equals 2, but here we need to consider the discriminant b squared minus 4ac, which is minus 1 squared minus 4 times 3 times 5, which is 1 minus 60, which is minus 59, which is less than naught. And so we can say with confidence that therefore no real roots of the quadratic factor. So therefore x equals 2 is the only real root of f of x equals naught. Also, just to mention at this point, whenever you see the words show that or prove, make sure you finish the question with some sort of conclusion. It can be quite brief, but don't just abandon the question and move on to the next one before you've properly answered it. Sometimes they'll penalize you, sometimes they won't. I haven't said anything new here, but I've finished with the answer to the question, which was show that it has only one real root, and that is my final statement. Okay, that was question 2.